Hello friends, welcome to Mu Lessons. Today in this video we will discuss about one of the most important topic of engineering mechanics, that is truss. So this is just a simple figure to give you idea about truss. So you have seen these type of structures when roads are made, buildings are bridges, all these types of structures, complicated structures having number of bars and joints so that they will balance the whole structure of the body. These are known as truss. So in this video we will start with two important structure types, that is the truss and the frames. The structures composed entirely of two force members is generally known as a truss, and the structure containing at least one member acted on by the force at three or more points is known as the frame. So that means if a particular member is acted upon by some of the external forces, means there will be n number of external forces, then it is known as a frame, and if it composed entirely of any two members force, then it is known as the truss. The plane truss lie in a single plane, you can see from this picture, and the space truss, they don't contain in a single plane or not loaded out of the structure plane. That means there is a special arrangement for this space type trusses. Now when studying about this truss, we have these bars, corresponding bars nearer to each other, we have the points, this is the joints, and we will calculate the force acting on these joints. So now if I will draw a simple diagram for this, then the point or this F point will seems to be like this, the four bars attached to this F point. So we had to make certain assumptions before starting this. So there are four basic assumptions, like the truss members are connected together at the ends only. So we have to consider that these members are connected together at the ends only. That means there will be no lagging of other components of that particular plane. When the truss members are connected together by the frictionless pins, that means they can move easily, they can rotate easily. The truss structures is loaded only at the joints. The weight of the member may be neglected, so you can neglect the weights. So these are the basic four assumptions which you need to make before studying all about this truss. Now these four members give rise to four members of two force members. That means in this case you can see F, that is a force acting on these two joints. This is also a truss member, and in this case this right angle triangle bar, L shaped bar, you can consider this force as a truss member, because in both the cases they are lying or they are acting on the same line of plane, same line of action. Now what are the straight members? That means the force act along the axis of the member, as I have shown in the last slide. That means both of these forces act on the same line of action. In this case these forces are towards each other, that means it is a compressive force which tends to shorten the member. So every time you see such a slab or a bar, you will consider it as a truss member. Now in this case it is not compression, it is elongation of this truss member, because the forces are moving apart from each other. That means the tensile forces tends to elongate this member. So these are some idea about the straight members in case of truss. Now what is a rigid truss? The truss will retain its shape when moved from its support. That means if they are connected to any of the supports, and if you move that support, the truss will remain in the particular shape, and that is why we call it rigid. Simple truss are constructed by attaching several triangles together and allows a very simple way to check rigidity. Now from this, if you remove this support also, the structure will be same, so it is a rigid truss. So in this case what are we looking for? The support action, the force in each membrane. Now for calculating all these things, that is the support action and the force in each members, here we have 1, 2, 3, several number of truss members. So we need to calculate the force in each members and what is the support reactions. Now how many equations are available? How many unknowns we need to calculate? Now each joint can have two equations, and unknowns minus is the number of members plus the number of reactions. This unknown, total number of unknowns is equals to number of members, number of truss members plus number of support reactions which they are experiencing. So if we know all these things, we can easily calculate them. Now there is a stability criteria in the study of truss, that is we write m is equals to 2j minus 3. Now in this case 2j is equals to number of equations to be solved, that means how many particular equations we need to solve, that is given by 2j. M is the members, total number of members in the structure, and 3 is the number of support reaction. So the maximum number which we have taken is 3, that is number of support reaction to each member is 3. Now there are some cases like for stability, if this M is equals to 2j minus 3, then it is a stable condition. Now if M is less than 2j minus 3, that means if the number of members is less than 2j minus 3, then it is unstable truss. And if M is greater than 2j minus 3, then it is statistically indeterminate, means you can't determine if it is stable or unstable. But if it is exactly equal to 2j minus 3, then it will be stable. Now let us see an example. Here a number of truss, that is a triangular shape members, are attached to make such a structure. You can see from this picture, and now A and E points are the supporting points. Now in this case, what is the number of members? If you calculate all these things, all these number of members, that will be 13. So M is equals to 13. Similarly J, that is the number of joints, you can calculate, that is 8. So you can easily calculate 1, 2, 3, 4, 5, 6, 7, 8. 8 number of joints are here. So what is the number of supports? Number of supports is 3. Supports 3. That means M is equals to 2j minus 3. It is exactly equal. That means it is a stable structure. Now let's discuss about the method of joints. After discussing all these things, we will go on to the numerical part. Now we are taking a reduced figure of the same of the previous slide, that is separate free body diagram for each member and each pin we have to draw. That is about the method of joints. Now we need to calculate the equilibrium equations for each pin, that is net F or the net force acting on them is 0. That means no moment equations. As it is a stable stress, this means there will be no rotation, so no moment equation. That means summation of all the forces will be 0. So here we come with an example. Use the method of joints to determine the force in each member of the truss. State whether each member is in tension or compression. So you need to consider if it is in tension or compression. So don't get confused with these units, feet, lb. So we will go throughout this video using these two units. In our Indian author books, it is just like in meters or centimeters, and this is in kg. So don't be confused, it has nothing to do with our solution part, they are just units. So here we consider a truss. The structure is quite simple, you can see. So how can we solve it? Now we consider the joint D, that is at below. Now at joint D, how many forces are acting? We need to consider. There are 4 tensions: AD, DC, the weight downwards, and the tension BD upwards in the y-axis. So we'll draw a free body diagram on joint D. Now in this case, net force in the y direction, that is TBD minus 3000 is equals to 0. Because as it is not moving any of the directions, it is rigid stress. So net force in the y-axis is equals to 0. So TBD, that is the tension, TBD is equals to 3000. Clear? Now the other two, that is TAD and TCD, balance each other. Now we'll draw the free body diagram of joint B. And similarly, we draw the diagram for joint B, but in this case there are three downward forces making some angles: TAB, TBC and TBD. Similarly, for this case we can resolve this TAB into two components. Here we will get TAB cos theta, TAB sin theta. Similarly for the case of TBC, so you are aware with all these resolutions and all. Previously we have seen in many of the previous videos. So as it is stable structure, we will consider net force. As we are progressing with the method of joints, so no moment equation, there will be no moment equation, that means there will be 0. So summation of forces in x axis and y axis should be 0. Now summation for forces in x axis we will calculate TBC sin theta minus TAB sin 60 degree is equals to 0, and for y axis it is minus TBC cos 30 minus TAB cos 60 minus TBD is equal to 0. So simply by solving these things you get all these tensions TAB and TBC, and mark here TAB and TBC came to a negative, but we are taking, for the time being we are taking it as positive. So we are just taking here the magnitude. Now what does it tells? In this case TBD is equals to positive. Directly we get the positive value. That means it is for extension, that is the tensile strength. And now in this case we get the negative value. That means this TAB is a compressive tension. This negative sign tells you about the compression part. But in this case we are just considering the magnitude. So always remember, in the questions we are asked, which one we have to show which is the compressive tension and tensile strength. So if it comes negative then it is compression, if it comes positive then it is elongation. Quite simple. Now we are left with two unknowns, that is these two parts. Now we'll draw the point at joint C. Similarly we'll draw all these points. In this case TBC is known, CY is known. So again by solving in the x direction we get TCD equals to 1299, and this is positive, so it is a tensile strength or elongation. Now we are left with another joint, that is actually we have started with this joint D. Now we will just substitute to get this joint AD. So in this case also we get joint AD equals to 1299. So from the previous diagrams also we have seen this joint CD and AD has to be equal. So here it comes to be equal. As they are positive, they all are shows that elongation. So this type of problems are quite simple to solve, because the number of members are less, number of support joints and reactions are also less. But when we will come across long chain of members, then you need to solve it very keenly so that you will get the perfect answers. Now talking about the zero force members, now look at this diagram. This is a triangular joint, the fixed horizontally with the wall. So similarly in this case also we'll draw, first of all we'll start from a point where you have minimum number of variables. So we start from C, we go for Fy equals to 0, then we get Fcd equals to 0 and Fx equal to 0, and that implies Fbc is equals to 0. Similarly the members BC and DC are zero force members. So this shows that the members BC and DC are zero force members. That means no force, tensile or compression is acting on them. They are experiencing totally zero force. Now we will draw the free body diagram at joint B. We will progress in a similar way. When acting on this point joint P, we also can get FBD is equals to 0. Now again progressing with another point, that is joint D. So first of all we'll start with this such a point where less number of variables or unknown are there. Then we'll progress towards the main truss or the supports. Now by calculating the free body diagram at joint D also, we'll find FAD is equals to 0 and so on. Here is another example. This is little bit critical. The truss shown in this figure support one side of a bridge and identical truss supports the other side. Floor beams carry vehicles loads to a truss joint. Calculate the force in the members BC, BG and CG. These are marked with the red color lines. When a truck of weight 7500 lb is stopped in the middle of the bridge as shown, the center of gravity of the truck is blah blah blah. So you can quietly understand what is going to happen in this case. So you need to calculate the truss. All the measurements are given. Now start with the solution part. Now first of all we will start with the middle one, that is the downward direction. Now the truck is resting on this bar, or you can say it is a member. Now we draw the free body diagram for symmetry. FH is equals to FF, free body diagram on the floor beams. Now we'll calculate all the values of GF and all from this diagram. You have to progress in a similar way as we have progressed in the previous slides about the first example. Now we'll draw the free body diagram on floor beams FH. Here is the free body diagram of FH. Now after getting some of the values, you can calculate this alpha, beta and phi, because some of the values are known from the previous slides. Now again, for the complete free body diagram of the complete truss, we need the picture of a complete truss. So remove the truck and just note all the forces acting on the joints, the reactions and all these things. And again, by the method of joints, show that there is no moment equation. That means summation of fx equals to 0, summation of fy equals to 0. Now similarly, by solving, you get ax and ay. Now draw the free body diagram of point A. Here three forces are acting: ax, ay and another tension ah. This is the figure. So by solving all these equations, these are some just resolution of forces, solving them. But the basic thing is you need to start from a particular point where there is minimum number of variables, then you progress accordingly. Or if you start with that problem, any of the points you can start, keep the variables as it is, then go on solving for different points which you want. Again, drawing for the free body diagram of joint H, we'll get some terms, that is TH in common, and putting the value of TH from this joint A to joint H, we'll get TB. So remember, TAB came negative, that means it is a compressive strength, and in this case it is positive, that is it is tensile strength. Just go on solving in a similar manner. Now again we start with the point B. So in case of point B, 1, 2, 3, 4 types of forces are acting, and need to resolve all these forces. You can see from this picture, you need to resolve all these forces. So after again using the method of joints, that is summation of fx is equals to 0 and summation of fy equals to 0, all the values are solved. The negative part for T tension BC means it is a compressive strength, and the positive part means it is a tensile strength, or the elongation part. Similarly, for the drawing the free body diagram of joint C also, summation of fx and fy is equals to 0, and corresponding values of TDC and TCG are given. So in this way you need to carry out with all the problems. And there are some practice questions, just simple questions with the answers shown. You can try. So we'll come with more number of videos regarding this engineering mechanics in the future time.